All right, the second video is going to be problems 7, 8, 9, and 10, 7 through 10. We're going to solve a couple of system by substitution, a couple of systems. So remember, a system is two or more equations. So in number 7, we're solving the system. We actually do have two equations. We're going to solve it by substitution. I want you to notice the first equation, the y is already by itself. So I'm going to take this expression and I'm going to replace the y in the second equation by x squared plus 6x minus 7. So we're going to have x squared plus 6x minus 7. That's what is replacing the y. I still have my plus 7 and my equals x. This piece right here is taking the place of the y in the second equation. So what we now have is the negative 7 and the positive 7 canceling each other out, or zeroing each other out. So we have this equation right here. Now it's a quadratic, so we're going to set it equal to 0 by subtracting an x from both sides. And 6x take away 1x is 5x. X take away x is 0. That I can factor. Don't forget, you need to look for the GCF. X squared and 5x have a common factor of x. So I'm going to pull out the common factor of x. Divide x squared by x, we get x. Divide 5x by x, we get 5. X times x plus 5. Look at it. If you distribute the x, you do get x squared plus 5x. If a product is equal to 0, one of the factors must be 0. So x equals 0. Or x plus 5 equals 0. All right, x equals 0. We can't do anything with that. And x plus 5 equals 0. We get x equals negative 5. Now, remember, when we're solving a system like this, we're looking for a y to go with that x. So you can either substitute into the second equation or you can substitute in the first. It really doesn't matter. If you wanted to put it in the first equation, you can. And maybe that's good practice. Or you can put it in the second. Doesn't matter. You put it into the first, it's super easy. Y equals x squared. At least the 0 is easy. The negative 5 is not quite as easy. We plug in the x equals 0. We get 0 plus 0 minus 7, which is negative 7. Think about that. 0 times 0 is 0. 0 squared is 0. 6 times 0 is 0. You get 0 plus 0, take away 7, which is negative 7. Okay, so one of my solutions is going to be 0 comma negative 7. Let's find the other one. I can either substitute the negative 5 into the first equation or the second. It really doesn't matter. If I want to plug it into the second equation because it looks easier, I think it does look easier, I'm going to plug it in there. So I'm going to use this one and plug in the negative 5. Negative 5, oops, who am I plugging the negative 5 in for? I'm supposed to be plugging it in for the x, right? Y plus 7 equals negative 5. Subtract 7 from both sides. We're going to get that y equals negative 12, right? So the other solution to this system of equations is negative 5, negative 12. And I think I'll write it right over here because that's where I have space. Negative 5, negative 12. And we have that one solved. Okay, problem number 8. Solve the system by substitution. Again, notice the y's are by themselves. So I'm going to do a little quick substitution. I'm going to take this expression for the y, put that into the second equation in place of the y. So we have negative x squared plus 4x plus 4 equals x plus 6. I'm going to set it equal to 0 by subtracting an x from both sides and subtracting a 6 from both sides. So we'll have negative x squared plus 3x minus 2 equals 0. I don't like factoring when I have leading coefficients that are negative. It's hard. So I'm going to multiply both sides of this equation by negative 1. So multiplying by negative 1. That changes this to an x squared minus 3x plus 2 equals 0. Now it's going to be easier to factor. Okay, a times c is 2. I need two numbers that multiply to create 2, and they have a sum of -3. That'll be -1 and -2. All right, if you need the box method to factor this, then we'll use the box method. So we draw our box that has 4 squares in it. First term gets the first square. Last term gets the last square. Middle term gets split into 2 pieces. Find the greatest common factor for the top row. X squared and -x are both divisible by x. They both have a factor of x. -2x and +2 are both divisible by -2. Both have a factor of 2. First column, x squared and 2x are both divisible by x. And then the second column, we got a -1. Does that multiply back together to create x squared minus 3x plus 2? It's always a good idea to check. It does. So we've got our factorization, x minus 1 times x minus 2 equals 0. We'll set each factor equal to 0, because the only way the product can equal 0 is if one of the factors is 0. So if we add a 1 here, we get that x must be 1. We add a 2 here, we get that x must be 2. Okay, we've got to find the y values that go with those x's. I'm going to use the second equation because it's real super simple. Y equals x plus 6. So if x is 1, y is going to be 7. If x is 2, y is going to be 8. So we get 2 solutions. We get 1, 7. When x is 1, y is 7. When x is 2, y is 8. So 1, 7 and 2, 8. Those are our 2 solutions. Right, and we're going to move on to the next problems, which are solving systems of equations by graphing. So let's take a look at those. All right, I'm going to switch it up here a little bit. And I'm going to pull up a little different space to work in. And I'm going to pull up my desmos because we're going to graph these on desmos. When you get to the test, you're going to have a problem that you have to graph by hand. And it'll be an easy one. So I'm going to grab my desmos. I've got my 2. Let's start on number 9. Okay, so here's my desmos. I'm going to type in for number 9, y equals x squared plus 3x plus 2, that quadratic, and then the equation y equals x plus 2 is that line. Notice the intersection points, -2, 0 and 2, 0. I'm going to make this smaller so I can do my graph over here at the same time. So my line and my quadratic. So my quadratic is going to go through the y-axis at 2. It's going through the point, get it right there, -3, 2. It's got its vertex at -1.5, -1/4, or just below the x-axis, barely below. It's got a y-intercept at -2, 0. That's one of our intersection points. Or not a y-intercept, sorry, an x-intercept, right? X-intercept at -2, 0. Another x-intercept at -1, 0. And my quadratic, my parabola, looks like this. Oops. Let me draw that side again. So there's my quadratic. My line is a slope of 1. Y equals x plus 2 has a slope of 1. It's going through here at -2, 0. It's going through there at 2, 0. And those are the only 2 places where the line and the quadratic are going to intersect. So on our paper, we're going to write down for our solution, -2, 0 is one of the intersection points. The other intersection point is 0, 2. And we are finished with problem number 9. Okay, let's do problem number 10. I'm going to first graph them on desmos. Y equals negative x squared minus x plus 6, and y equals negative x minus 3. So let me pull out my desmos, make it bigger again. And I'm going to graph the two different equations. So problem number 10, y equals negative x squared minus x plus 6. It's y-intercept at 6. The parabola opens down because a is negative 1. The vertex is right here at negative 1/2 and positive 6.25. Remember that formula, h equals negative b over 2a. For that quadratic, b is negative 1, a is negative 2, and negative b over 2a would be negative 1/2. Okay, but desmos does all that for us. Let's put in the second equation, y equals negative x minus 3. And, well, there we go. We've got solutions or intersection points at negative 3, 0, and at positive 3, negative 6. So the solutions to our system of equation are going to be those 2 points. But we need to draw our graph. So we will do that. So the quadratic, y-intercept at 6. It also goes through negative 1, positive 6. It's got its vertex. Remember what we said it was? Negative 1/2, positive 6.25. So just barely above 6. And where are we going? We're going through the point negative 3, 0, which is one of our intersection points, one of the solutions to our system. We're going through positive 3, negative 6. I think we can draw a pretty good graph from there. Maybe notice that your parabola actually goes through the x-axis also at 2, 0, right? And we're going to draw our quadratic. Opening downward because a is negative 1, right? There's our quadratic. Opening downward. Our line has a slope of negative 1. Notice in problem number 9, the line went up from left to right because the slope was positive 1. Notice this one is going down from left to right. Slope is negative 1. Okay. Notice our y-intercept is negative 3 for that line. It's going through the point negative 3, 0. It's going through the point 3, negative 6. Notice where it's going with that slope of negative 1. All right. Going through corners of those squares. And there's our graph. But we're not done. We have to write down the coordinates of the intersection points. The solution to the system is those points of intersection. So you have to write them down. Negative 3, 0, 3, negative 6, which is this point over here. And there's the solution to our problem number 10. Okay? All right. The next video is going to show the last 4 problems on this review assignment.